Hello everyone. Today we are going to see how to find an initial basic feasible solution to a transportation problem using Vogel's approximation method. So I have taken one problem of transportation. So now there are three sources and four destinations. And you can see the supply units are 120, 70, and 50. If you add the supply units, they sum up to 240. And the demand units at each destination are 60, 40, 30, 110, respectively. That also sums up to 240. So the first step to solve the transportation problem is to check whether it is balanced or not. So this is a balanced transportation problem. So we'll move ahead now. So now let us see how to apply VAM, that is Vogel's approximation method. So we want to calculate now the penalties, the row penalties and the column penalties. So this is the first step to proceed with VAM, that you calculate the row penalties and column penalties. So I'm calculating the penalties here. So row penalties. So for each row, we will find the smallest entry and the next smallest entry. And the difference between the smallest entries is penalties. Okay, this we will do for each row and each column. If there is a tie in the smallest costs, then the corresponding penalty will become 0. So let us go row by row. The first row, the smallest entry is the smallest entry is 4 and the next smallest entry is 17. So the difference between 4 and 17 is 13. Second row, the smallest entry is 7 and the next smallest entry is 9. So the difference between them is 2. Then in the third row, if you see, the first smallest entry is 15 and the second smallest entry is 20. The difference between them is 5. Similarly, we will calculate all the column penalties. Okay. Now, in the first column, the smallest transportation cost is 20 and the next smallest transportation cost is 24. So the difference is 4. Next is next column that for destination 2, the smallest cost is 22 and the next smallest cost is 37. So the difference between them is 15. Third column, similarly, 9 and 17, the difference is 8. And the fourth column, the smallest entry is 4 and the next smallest entry is 7. So the difference is 3. This is how we have calculated the first set of all penalties. Now, we will see the largest penalty among all these 7 penalties. And that largest penalty you can see here is 15. So this indicates that we can make our first allocation in the corresponding column. This largest penalty 15 belongs to the second column. So we will go in the second column. We will look in the second column for the allocation. And as we are interested in finding the minimum transportation cost, we should look for the minimum transportation cost in this column. And that belongs to the cell 1, 2, where the transportation cost is 22. So this 1, 2 is related to source 1 and destination 2, where the supply available is 120 units and the demand is of 40 units. So we will give all 40 units that are required at this destination. And that is how the requirement at this destination is fulfilled. And therefore, we will not supply any more units at this destination. So I am just cancelling it out. so that in future, in the next steps, we will not consider this destination again. So there are no more units required at destination 2. But at source 1, after allotting 40 units, we are left with 80 units. Okay. Now, for the remaining transportation table, we will again calculate the penalties. Okay. So let us calculate the penalties again. The next penalty set, row penalties, again the same logic. So the first row, again 4 is the smallest cost, 17 is the next smallest cost, and the difference is 13. Second row also remains same. Third row remains same. Now I'm writing the second row, second set of column penalties here, as there is a space issue. Now first column penalties now again are 4. Now second column, we won't calculate the penalties as there is no more units required at D2. Third column, the penalties remain same. And the fourth column, again, same. Now among all these 6 penalties, the largest penalty, if you see, is 13. Okay, so here we are going to make the allocation. Okay, so let me just put an arrow here. Okay, now the largest penalty belongs to the first row, and in the first row the smallest transportation cost is 4, that is in the row 1 column 4. Okay, and the situation is at destination 4, 110 units are required while we are left with only 80 units, and therefore we will give all 80 which are available, and that is how the supply at source 1 is exhausted completely, utilized completely. So there are no more units available at source 1, but there is a demand of 30 units at destination 4. So that 30 I have written again. Again, we will calculate the next set of penalties. Now, there are no more units left in the first row, that is at first source. So, the first row penalty we will not be calculating. Now, second row penalty remains same. Third row penalty remains same. Now, the third set of column penalties I'm calculating here again. So the first column penalty, now that 20 is gone, S1 D1, the transportation cost was 20 and that was the smallest one. That is gone and therefore column penalty is going to change. The first smallest entry is now 24 and the next smallest entry is 32. So the difference between them is 8. The third column, again it is changed. First smallest entry is 9 and the next smallest entry is 20. So the difference is 11. And the fourth column, the difference is 8. Now, among these 5 penalties, 11 is the largest one, which corresponds to third column. Now, in the third column, the supply available is, sorry, the demand required at, demand is of 30 units at destination 3. And yes, 11 is the largest penalty, and that corresponds to the third column. That means third destination D3, and in D3 the smallest transportation cost is 9, which corresponds to the source 2 and destination 3, where we are required 30 units and the available units are 70. Therefore we can give all 30 units that are required at D3, and that is how the requirement at this destination is fulfilled, satisfied. So there are no more units required at destination 3, but from source 2 we have utilized 30 and we are left with 40 more units. Okay, so now we are left with 2 rows and 2 columns. So again we will calculate the maybe the last set of penalties. Let us see. So the first row, no penalty. Second row, the next smallest cost was 9 in the previous stage. That is gone, and therefore the penalties are going to change. The first smallest cost is 7 and the next smallest cost is 24. So the difference is 17. Third row, that is source 3, 15 and 32. So the difference is again 17. First column, the difference is of 8. Now, third column is also gone. The destination 3 has got all its required units supplied, and therefore third column penalty will not be calculated. Fourth column penalty will be 8. Now, there is a tie in the largest penalty. Okay, both row penalties have become 17. So we should go, or we should look in the corresponding rows for the least cost. In the second row, if you see, the least cost is 7. And in the third row, if you see, the least cost is 15. So we have to check which is the least between these two now. So obviously 7 is the least cost. So we will mark the second row for assignment. Okay, where the penalty is 17 and the corresponding least cost is 7, which is smaller than 15. And therefore, we have chosen second row for allocation. 30 units are required and 40 are available at source 2. So we will give all 30 that are required. And that is how the requirement at destination 4 is fulfilled. And now no more units are required at D4, but at source 2 we are left with 10 units. Now we are left only with two cells, that is S2 D1 and S3 D1. So at S2, as per the algorithm, we should go for the least cost. And as it is a balanced problem, we are going to get exact allocation at the end. So S2 D1, the situation is 60 units are required and 10 units are available. So we can give only 10 units. Though the cost is smallest, we cannot provide more than 10 units because source 2 has only 10 units. So these 10 units are provided and there are no more units left at source 2. But at destination 1, 50 more units are required and 50 units exactly are available at S3. This happens because your TP is balanced. Okay. And this is how we get the allocations for VAM. And now we will write our allocations. Okay. So this is how we are getting it. This is our final answer. So how to write the allocations? Let us see here. So the allocations are, they correspond to first row, second column. So we will write X12 is equal to 40, X14 is equal to 80, X21 is equal to 10, X23 is equal to 30, X24 is also 30, X31, X31 is 50, and we are getting exactly 6 allocations. You can see we are getting exactly 6 allocations at independent positions. At independent positions means we are not able to draw any closed loop around these allocations. So this is a perfectly non-degenerate IBFS. Okay. So let me tell you once again. Yeah, these are our allocations, and therefore so we get, how we conclude this? We get exactly 7 allocations. Allocations means where we have put units. Okay, those cells become occupied and those units are called as allocations. We get exactly 7 allocations at independent positions Therefore, this IBFS, this is just an initial basic feasible solution. Okay. This IBFS is non-degenerate. Okay. So we can calculate the final transportation cost now. Total transportation cost is equal to, how to calculate this now? We will multiply. See, in the transportation, all of you know that every cost is the cost of transportation of one unit of product from that particular source to that particular destination. So 22, our first allocation is done in the cell where the TP cost is 22. That means for one unit of product, the transportation cost from S1 to D2 is 22 rupees, and we are transporting now 40 units. So that cost becomes 40 into 22. So 40 into 22 plus 80 into 4 plus 10 into 24 plus 30 into 9 plus 30 into 7, 30 into 9 plus 30 into 7, plus the last one we have got is 50 into 32. So that final answer would be, we will calculate it here, 880 plus 80 into 4 is 320 plus 10 into 24 is 240 plus 30 into 9 is 270. 30 into 7 is 210 plus 32 into 50, that is 1600. Okay, so the total cost is 2, 8, 10, 13, 15, 17, 19, 25. So 3520. So total cost is rupees 300,520. So this is how we can apply VAM. So the only thing you have to remember is if there is a tie in the largest penalties, then you have to select that row or column where there is least cost. You check all the least cost. If there is a tie in the least cost also, then you have to break that tie. How will you break that tie? If there is a tie between the least costs also, I mean, the penalties are also same, the corresponding least costs are also same, then choose that cell where you can put maximum allocations, maximum units. Okay, that is how you can always break the tie. So thank you friends for listening to this video carefully, and I hope this will help you a lot in developing the skill of solving a transportation problem. And please remember, VAM is the best method to find an IBFS. Okay. Mostly the solutions which we get using VAM are optimal solutions themselves. So when we apply the modified distribution method, we observe many times that the solution obtained by VAM is the optimal solution. In our next video, we will see how to optimize the IBFS using MODI method. Thank you very much.